There it goes. Okay. So today we're still on graphing sine and cosine. This time we're going to focus a little bit more on pulling characteristics from a function and then also taking characteristics of a sine or cosine function and turning it into an equation. Or a graph, taking a graph and turning it into an equation for sine or cosine. So go ahead and grab your notes or whatever it is you're using to take notes. It could be a Google Doc, although that would be kind of hard, or notebook, preferred method. And let's get started. That's geometry. Come on, catch up. There we go. Here's my pen. Okay. 4.4 sine and cosine graphs continued. Okay, so yesterday was a short class period, and we kind of briefly talked about looking at a graph and figuring out things like the amplitude and the period and the vertical shift and stuff like that. Today we're going to talk a little bit more about what the equations look like when we've got vertical shift and stuff like that. So the standard form for a sine or a cosine function is f of x equals a sine of bx plus c plus d, or for cosine then f of x equals a cosine of bx plus c plus d. So we're going to jump right into finding things like amplitude, period, phase shift, vertical shift from the function itself without even looking at the graph. You could always type the function into a graph. That's kind of a workaround you could have had for yesterday's stuff if you wanted to. You could type the function that it gave you into Desmos or into your graphing calculator and then figure out the characteristic it's looking for. But you can also do it directly from the function. So a few different things we're looking for. The amplitude. Amplitude is A. So whatever number is in front, whatever coefficient is there, that is your amplitude. The period. The standard period is 2 pi. So 2 pi divided by the absolute value of b would be your new period if your period is different than the standard period. If b is 1, then the period would just be 2 pi. The phase shift also known as the horizontal shift is found very much the same way that you find horizontal shift when you're looking at quadratics or any other kind of function. It's going to be negative c over absolute value of b. But another way that you can kind of think about this and find it, if you think about how you would find, just for a moment, we'll take a little detour over here. When you think about something like f of x equals x squared as the parent function, and f of x equals x, we'll go with 2x minus 4 squared. Go g of x equals 2x minus 4 squared. If you're going to find the horizontal shift for this thing, you would do it in a very similar way that you would do for this, whatever's in the parentheses. We would factor out that 2, and then, which is kind of what you're doing in dividing by absolute value of b here. We're factoring out that b, and then isolating this part. So in this case, you'd end up with 2 times x minus 2. By factoring that out, you can isolate the part that's changing the x, right? So it's the same kind of thing that we're doing here with the phase shift. It's just a different name for horizontal shift. And it deals with what's inside with the x. And then likewise, vertical shift deals with what's outside with the y. So that's where that plus d part comes in. So the vertical shift is just d. And then the equation of the midline is just y equals d. So if you were trying to plot the midline like on Desmos or on your TI-84, you would just put in y equals whatever that d value is, and that'll be your midline for the function. And that's another way that you can help find amplitude and things like that, you know, from the graph itself or even from this, even though we already know that amplitude is A. Okay. So let's do a couple of examples where we're finding things like amplitude, period, vertical shift, phase shift, and stuff like that just from the equation. So first example. We'll go f of x equals 4 sine of 2x minus 1 plus 7. And we want to find all of these different things: period, phase shift, amplitude, vertical shift, all that good stuff. So personally, what I would do is just identify what those letters are, the A, B, C, and D values. So that's the first thing I would do. I go, okay, well, that's A, B, C, and D. Because then it becomes kind of a game of plug and chug. You could also find it by graphing that function and taking a look at, you know, what the graph looks like and finding the characteristics from there. But I find this to be a little bit easier. So the amplitude then is just 4. The period, 2 pi over absolute value of 2, which is just then pi. Phase shift, or let's call it PS to abbreviate. Negative c, so if c is -1, negative c would be -1 or +1 over absolute value of b. So that would just be 1/2. The vertical shift, d was 7, so vertical shift is 7. And if we wanted to, we could also identify the midline. Y equals 7. So we can find all of those things just from looking at the function itself. Okay. Any questions so far? Any numbers we're not sure where they came from? Any steps we're not sure why they happened or how or anything like that? Okay. So that was kind of the missing piece from yesterday. So sorry about that again. Next thing we're going to do, well, we'll do one more of these. I'll have you guys try one. So you're going to find amplitude, period, phase shift, vertical shift, and midline for, we'll call this one f of theta. So that's the Greek letter theta. A lot of times you'll see that referred to in when we talk about angles, when we talk about functions involving sine, cosine, tangent. Sometimes they'll use the variable theta instead of x. When you go to Desmos, make sure whenever you get a function that has theta in it instead, replace it with an x, because Desmos like x better. Same with your graphing calculator, TIs and stuff like that. You can change it so that the variable is theta, but it's a little bit easier when the variable is x. So just keep that in mind when you use a graphing calculator. Replace thetas with x's, but sometimes we'll see ones with theta instead. So I want to make sure that we get that figured out. Okay, then we'll go -1/2 cosine of pi x minus 3. So give this a try on your own. Try finding amplitude, period, phase shift, vertical shift, and the midline. Keep in mind that not all of these things might be present. Sometimes the vertical shift is 0, or the amplitude is 1, or something like that. So not everything is always changed. But give it a try. When you think you've got it, type "got it" in the chat. Make sure we start by identifying those letters. If that's what you did, you're on the right track. If it doesn't have a particular letter or a particular value, like in this case, it doesn't have C, so C would just be 0 because there is no C value. All right, so someone who thinks they have it, what do we think the amplitude is? Any ideas? Anybody out there? Amplitude. Yeah, nice. It is 1/2. The only thing to remember on amplitude is that you can't have a negative amplitude. So it is positive 1/2. So I guess it should be, if you're considering the negative sign in there with the A, oops, sorry, can't see what I'm referring to up there, then we would want it to be absolute value of A. What the negative tells us, just like with any other function, kind of like we were talking about, like f of x equals x squared or anything like that, the negative out in front tells us if it's reflected or not. So in this case, cosine typically starts up at the top. This cosine would start down at the bottom and then go up and continue its wave. A sine function that's reflected would start still at that midline, but it would go down instead of going up to start. So that's another interesting thing to think about. Anyway, yes, you guys got it. Amplitude is 1/2. What do we think the period is? We know it's 2 pi over absolute value of b. Which is just 2 pi over pi. So what do we get with its 2 pi over pi? Yeah, just 2. The pi's cancel. The period is 2. Okay. On this one, the phase shift is easy. What's the phase shift? Is there a phase shift? Yeah, 0. There is no phase shift here. C is 0, so phase shift is 0. Those ones are usually people's favorite. How about the vertical shift? Yeah, -3. Good stuff. And then the midline is just y equals and the vertical shift. Okay. There is one that I left out. It's the frequency. If you've taken physics, you might have heard about frequency, or like other science classes, I think too, have talked about frequency, maybe in your freshman science or middle school science, stuff like that. Frequency, usually when you're talking about waves and things like that, right? So frequency is just the number of cycles per second. So frequency would just be 1 over the period. Or in this case, you can just flip it and have it be b over 2 pi. So it's the reciprocal of the period. So in this case, our frequency would just be 1/2. Okay. So here we go, quick poll. Do we want to do more examples of this, or do we want to move on? Go over to the poll section and let me know what you're feeling. All right. Got 30 seconds more to vote. I'll let people finish writing. Okay. So it looks like about 90% of our votes are for moving on. So if you would like more examples of this, we can do more examples of this at the end. But we are going to move on to the last kind of question that we're going to see today. So the other, and it's kind of in this same vein. The other kind of question we're going to see today is where they're going to give you things like the amplitude, the phase shift, the period, all that stuff, and you have to write the equation for the function. So that's what we're going to head to next. I'm going to grab a new piece of paper, and that's where we're headed. So we still need to have that whole mindset of f of x equals a sine of bx plus c plus d. And real quick, I'm going to make sure that that's the version that IXL uses as well. Yes, they do. Awesome. Because there are kind of two different versions that you can write this in. The other way is if you pull the b out and you have b times x plus c, but that's the less common way to do it, but some places prefer it. Anyway, I think they prefer it because it's a little bit easier to see the phase shift that way. But anyway, the IXL section prefers it written this way, as does our textbook. So, okay. So we're going to see things like, and these kind of, I guess, are easiest taught with an example. So, second example for today, we're going to be given amplitude. We'll say the amplitude is 4. Period is pi over 2. Phase shift is, what would be something fairly friendly here? Go 1 and see what happens. And then vertical shift is -2. And we're going to be told to write a sine function with these characteristics. Okay. So when we're writing a sine function or a cosine function, they'll tell you which they want with these characteristics. The thing that we're kind of thinking here is that we need to find what A, B, C, and D are going to be. If phase shift is 0 or something like that, or they don't mention a phase shift, then we automatically know that C or something like that would be 0. But in this case, we have all 4 components, so we need all 4 letters. So it's kind of like a little puzzle. We always know that the amplitude is A. So we need to find A, B, C, and D. That's kind of what we're thinking. We know the amplitude is A, so that tells me that A is 4, since we know amplitude is 4. The period can help us with B, because we know period is 2 pi over absolute value of B. So in this case, if I know that pi over 2 is going to be my period, then 2 pi over B equals pi over 2, and we want to solve that. So we can cross multiply. We get 4 pi equals B pi. Divide by pi on both sides. And we get that B is 4. So we found A and B already. And that's good because in order to find C, in order to find what's working with our phase shift here, we already need to have B because phase shift has two variables involved. So we've got the amplitude dealt with, we have the period dealt with, we know what A and B are. Now we need phase shift. We know that phase shift is negative C over B. And in this case, B is 4. And we know that our phase shift is 1. And just by looking at this, you can tell that it's probably going to be negative 4. But we can solve it by multiplying by 4 on both sides to get negative C equals 4. And then we can divide by negative 1 on both sides to get that C is negative 4. And then lastly, we have to deal with that vertical shift. Wow, it's raining hard outside. All right, so that vertical shift, well, we already know that vertical shift is D. So then D is going to be negative 2 because our vertical shift was negative 2. All right, so now we have A, B, C, and D. We just have to plug those in. So our final answer, f of x equals 4 sine of 4x minus 4 minus 2. Lots of 4s. Oh, I just noticed what I did on the other page. I said we were going to use theta, and I accidentally used x out of force of habit. That would have been pi times theta. Whoops. All right, anyway. Here's our function. Most of the time you'll be using x. I believe on the IXL you use x as well. Yep. Okay. So that's one kind of question that you're going to be asked. You're going to be given things like amplitude, period, phase shift, vertical shift, and be asked to write a function with those characteristics. So we go through, we find A, B, C, and D, and then we just plug those in. Any questions on this one so far? Any numbers we're not sure where they came from, or steps we're not sure how they happened or why, or anything like that? Okay. Then I'll have you guys try one real quick, and then we'll do one with graphs, and then we will be done. For this one, we want a cosine function. With amplitude of 1/2, period of 3, vertical shift of 10, and phase shift of pi. Yeah, okay. Go ahead and give that one a try. When you think you've got it, type "got it" in the chat. All right, if you got the a is 1/2, you're on the right track. I'm kind of going through here. The period was 2 pi over b. So that means that 2 pi over b is equal to 3 because we know our period's 3. So then you multiply by b on both sides and divide by 3 on both sides to get 2 pi over 3 for b. Now that makes finding c a little bit interesting just because you do have to deal with a little bit more in the way of multiplying and dividing with fractions and stuff like that. But phase shift is negative c over b. We know our phase shift is, sorry, did that wrong. Phase shift is pi. So you get, wow, this is an ugly one. 2 pi times pi over 3. So you get 2 pi squared over 3 is equal to negative c. So then negative 2 pi squared over 3 is equal to c. Didn't mean to make that one quite so ugly. But anyway, there we go. That's our phase shift. Or that's our c value, which makes our phase shift pi. Anyway, and then the vertical shift would be 10 because d was, or the vertical shift was 10, so d will be 10 because d is the vertical shift. So now we get to combine all of this. This time we're doing a cosine function. So f of x equals 1/2 cosine of 2 pi over 3x minus 2 pi squared over 3 plus 10. All right, so that was a little bit ugly, but we made it. The ones that you get on your homework will probably not be quite that ugly. Most of them will be quite a bit simpler than that, actually, probably until you get quite a ways into it, since IXL levels up as you go. But anyway, that's the main idea here. If you can solve that one, you can solve any of them. So the last kind of question that we're going to get, we're actually going to grab the IXL section itself and look at it because it involves looking at graphs and using the graph to determine the function, and they draw prettier graphs than I do on the computer. So with that, we are going to jump to that, and also I'll minimize this window so we can use a bit of both. But that's the one we want. There we go. Okay, so it'll say things like find the equation for the cosine graph in this format here. Wow, this one's not changed at all. Anyway, so we know that a typical cosine function has a period of 2 pi. We know that a typical cosine function has an amplitude of 1, and that a typical cosine function doesn't have any vertical shift or phase shift. This is your standard cosine function for the first one, so it's just going to be cosine of x. The second one, though, does have a little bit that is changed. We notice that this one starts from the bottom instead. Other than that, the amplitude is still 1, so A is still 1. The period is still 2 pi, so we don't have to change anything with the period. There's still no phase shift or vertical shift. The midline is still 0. So this one is just negative cosine. Let's find something a little bit that changed. Okay, this one changes it a little bit. So as you kind of go little by little, they're going to be adding more and more things that you're supposed to change, like the vertical shift or the phase shift or the amplitude. This one's got a different amplitude. It's still got the same period because from peak to peak, you still see we're going from 0 to 2 pi. But the amplitude is different. So this one is just 2 cosine. This one gets moved down and it has a different amplitude. So now we're starting to add in things like vertical shift. It's also got a different period. So this is one where we might want to start writing things down. So when you take a look at ones where you're dealing with a graph, especially when it's a bit less of a simple graph, I would start by looking and writing down things like amplitude, period, vertical shift, and phase shift. So for this particular example, it looks like the amplitude is 1/2, and you have to be careful when you look at the scaling on the graph. For this one, it goes up, like the midline is down at -3. It only goes up, or it goes up one full box, but that each box is only worth half in this case. So this one, the amplitude is 1/2. The period from peak to peak, it goes from 0 to pi. So the period on this one is pi. The vertical shift, where the midline is moved down 3, so our vertical shift is -3. And then this one does not have a phase shift. So I would start by writing those things down, and then it becomes a problem just like our other ones from the last example or two, where you're given an amplitude, a period, a vertical shift, a phase shift, and you need to find the equation for that function. So in this case, we know amplitude is A, the period, 2 pi over b. So if the period is pi, then you get 2 pi equals b pi. So b is 2. The vertical shift is d. And then c is 0 because we don't have a phase shift. So it becomes just like the ones we had done before. F of x is going to equal 1/2, since a was 1/2. Cosine, b was 2, so it'll be 2x. There was no phase shift, but the vertical shift was -3. Okay. So that's the other kind of question that you're going to see using a graph. Go ahead and try this one on your own. I'll zoom in so that you guys can see it a little bit better. Go ahead and try finding the equation that goes with that cosine graph. That'll be our last one as a group, and then we'll get the assignment and be done for today. All right, if you pulled from the graph that the amplitude was 2, the period is pi, the vertical shift is -5, and that the phase shift is 0, you're on the right track here. And then from that, if you got that A is 2, B is 2, D is -5, and C is 0, you're also on the right track here. We should get 2 cosine of 2x minus 5. Okay. So today's assignment is going to involve this IXL section and one other. The other one's more like the problems, like in example 2, when you're given the amplitude and the period and the phase shift and stuff like that. So I'm going to post those. We'll take a look and we'll get out of here. Okay, so in Google Classroom, might have to refresh the page. We're doing N3 and N7 to a SMART score of 80. So the first one is writing equations of sine functions using their properties. So it'll tell you things like the period, the amplitude, and contains the point pi 0. Interesting. Okay, so this one tells you about phase shift, I guess. One moment. Oh, this one tells you about where the midline's located. So if it says something like contains the point pi 0, that's one that you'll have to think about a little bit, but basically it's telling you about where the midline's located. So at over pi, that's half of the period. And at half of the period, it should be, for a sine function, at the midline again. So it's telling you that the midline is at 0 and that it has no vertical shift. Okay. So usually when it says stuff like contains the point, it's going to be referring to where the midline's located, I think. Let me double check and make sure there's nothing, or that there's nothing else weird like that. Okay, it contains point -pi 0. Yeah, that's also still just referring to where the midline's located at 0. And this one's saying your midline's located at 1. Okay, so when it says contains the point, it's talking about, generally speaking, where your midline's going to be, where your vertical, what your vertical shift is. But that's interesting. Okay. Then the other one is ones just like we were just doing. Just like this section, where you're writing the equation from the graph. Okay. If you want to go over more questions together, feel free to stick around. Otherwise, you guys are good to go and have a great rest of your day.